Hey everyone, welcome back. For the second half of this lesson, I am going to move through things a little bit faster. I've actually pre-typed all of the problems out. This has just been a long slog of a lesson practice. It takes a long time to get through this because it's so methodical. And we have to go step by step by step by step. And you're probably pulling your hair out a little bit thinking, I could do this much faster than this. But I'm warning you, if you do it faster, you're going to make mistakes. We're doing it thoroughly and carefully to assure that we always end up with the right answer in the end. And if we do end up with a wrong answer, it's really easy to go back and analyze because we have all the steps here so we can see exactly what we did wrong and fix it. All right, let's move on to letter F. This is just like letter E, except with a different arrangement of A and B. So in letter F, we're going to be taking negative A, and distributing it across negative B minus A. When I do that, the negatives cancel out. I get AB plus A, and let's see. When I multiply negative A times negative A, it's not just going to be A, it's A squared because it's A times A. So I distribute the A's, it becomes AB plus A squared, and then this minus B just comes along for the ride. Next thing I'm going to do is plug in my A's and B's. Again, it's 2 for A and negative 1 for B. So I'm going to plug in all of those values. And then when I simplify that, the first thing I'm going to simplify is my multiplication here. I'm also at the same time going to simplify my exponent. I could do those at the same time because really those are essentially the same thing. Here I'm multiplying 2 times 2, right? And here I'm multiplying 2 times negative 1. They're really at the same level, so I'm doing those at the same time. Technically, I should do the exponent first and then the multiplication, but here it really doesn't matter because it works out. All right? And when I add negative 2 plus 4 plus 1, negative 2 plus 4 is 2, 2 plus 1 is 3. That's my answer for letter F. Moving along to letter G. This one's a little harder because we have this big old fraction. Remember, the fraction bar serves as a grouping symbol. So here I'm going to plug in 25 for B, but notice it's negative B. So I start with negative 25 times, and I'm going to plug in negative 2 for A. Negative 2 minus 4 in parentheses here, plus 25 because it's plus B at the end, then divided by B. Now I see all these 25s in here. There's probably a way I could cancel this out, but I'm not going to worry about doing that right now. I'm just going to work the problem. First thing I need to do is what's in parentheses. So I'm going to simplify this negative 2 minus 4. Notice they have the same sign. It's going to be negative 2 plus the opposite of 4. That becomes negative 6. Next thing I'm going to do is the multiplication of negative 25 and negative 6. That equals 150. And then I can do the addition on the top because the fraction bar serves as a grouping symbol. So this is going to turn into 175 over 25. That can be simplified. Actually, 175, if I said 125, I meant 170. 175 over 25 can be simplified to 7. All right, letter H. In letter H, I'm going to do the same sort of thing, except again, I've got just this awful fraction that I've got to work with. But the best way to do these is just to get started on them. So I'm going to plug in negative 4 for X. I'm going to plug in negative 2 for Y. Notice in this one I have an absolute value symbol, the absolute value of negative 2. And remember, what the absolute value symbol does is it turns any value positive. So any value that comes out of the absolute value symbol, when I get rid of those lines, is going to be positive. So I'm going to do that. So first what I'm going to do is the negative 4 squared. Negative 4 times negative 4 is positive 16. I'm going to make this a positive 2. And then I'm just going to observe I'm taking negative 4 times a positive 2. Negative 4 is positive 4 times positive 2 is 8. And that's how I got this 8 up top here. In the denominator, I'm doing negative 4 to the third. Negative 4 times negative 4 is positive 16 times negative 4 is negative 64. So next, I'm going to add on top of the fraction bar. It's going to become 24 over 64. But whoa, wait a second. There's a negative on the bottom. That means if I have a negative anywhere, a single negative anywhere in a fraction, that means my whole fraction is negative. So I can just bring that negative up top or out front like this. And then can this be simplified? It sure can. Negative 24 over 64 can be simplified because both 24 and 64 are going to be divided by 8. So this becomes negative 3/8. All right, now, the hardest problem. The hardest problem in the whole assignment. And not because it's really the hardest problem, but because just the wording of it is hard to figure out. There's an example of this, by the way, in the chapter that if you're stuck on how to do this sort of thing, you should probably go look at that example. For this one, it says we have a savings account that grows according to the formula P sub y equals 1.04 P sub y minus 1. Now listen, these subscripts, these variables in the subscript, they are just awful because it seems like you should have to do something with them. And you kind of have to do something with them, kind of, but they're not mathematical operations. So it's not like you're multiplying or raising p to a power or something. It's just denoting which p we're talking about. P sub y is the principal for a certain year, okay? And that little y tells you we're talking about a specific year. So let's say we're talking about the year 2022 and 2021. P sub 2022 is a different variable than P sub 2021. They both have a P out front, so they both look like they're measuring similar things or they're referring to similar things. That's why we use subscripts, because we can actually have a P variable. It means principal, right? The principal that you're gaining interest on. But it's kind of confusing when you put variables as subscripts. The subscript doesn't change the number. It's not multiplying it. It's not a mathematical operation. It's telling us what principal we're talking about. All right, so that's what we're going to have to work with in this one. The principal of the current year is 1.04 times the principal of the current year minus 1. That means the principal of the previous year. Now let's see what's happening here. We say after 6 years, there is a principal balance of $1,600. How much is the principal balance after 8 years? So how are we going to figure this out? Well, first of all, let's get some terms down and figure out what we're talking about. The principal after 7 years, okay, I'm just going to note this, is 1.04 times the principal after y minus 1, 7 minus 1, or 6 years. Now, why is this important? Because we know the principal after 6 years, and we can actually plug it into our equation. So if you ever run into a problem like this, the place to start is to find a principal you know and plug it into your equation. We know the principal after 6 years. We can plug that into our equation to get the principal after 7 years, okay? And the way that looks is this. The principal after 7 years equals 1.04 times the principal after 6 years, the principal of the previous year. So 1.04 times 1,600 is $1,664. Now we're going to take that and we're going to pay it forward. The principal after 8 years is going to be 1.04 times the principal after 8 minus 1 years, or the principal after 7 years. Do we know the principal after 7 years? Well, we do now. We do now, right? So the principal after 7 years is 1,664. We plug that in, multiply it by 1.04, and we're left with a total amount in our account of $1,730.56. Now that may have seemed confusing. If you think that was confusing, I guarantee you there are other students who feel the exact same way. What you should probably do is go back to the lesson examples for lesson 16 and also take a look at the way the book describes it. So when you run into one of these, you know exactly what you're doing. This is the hardest type of problem you're going to run into. But now you are ready to work lesson 16, numbers 1 through 30.